This is section 5.3, and I just put these properties up here in case you wanted to pause it and write those down again for this section. This is a new equation that we're trying to solve where the variable is in the exponent. So typically what we've done is if the opposite of inverse or the inverse of adding or the opposite or how do you undo an adding is you subtract. If you are multiplying, how do you undo it? You divide. If it's squared, you square root. Another operation that we've done is absolute value. So none of those will work for this one. The only thing that's going to work is the inverse of an exponential equation, which is logging both sides. And whatever you do to one side, you have to do to the other. And that will come into practice, which would be this one right here. How do you get, if it was just m to the k, you have to have a log in front of it in order to bring that down into the front. So on this first equation here, first thing we're going to do is log both sides. We can do whatever we want just so that whatever we do to one side, we do to the other. This is the work that you're going to show. Even if you knew the answer, you would still show this work. This isn't as simple as some of them might be for you. Now that we have this, we can use that property that says we can bring the x in front of the log. So that's going to be log of 4600, which is just a number, equals x times the log of 10, which is just a number. And if you think about the log of 10, a shortcut, base 10 of 10, remember when we did that, what is that equal to? 10 to the question mark equals 10. That's just 1. So this right here is just 1. If we didn't remember that, we could get the x by itself, so we could divide by the log of 10. And I'm going to use my calculator to do this one. So we would have the log of 4600 divided by the log of 10. And we're going to get 3.6628, and I'm going to round this out 4 places. So x is 3.6628, and that's an estimate. So if you were to put that in right here, 10 to the 3.6628, 4,600 roughly, because we had to round it. All right, let's look at the next one. Same thing, the variable ends up being in the exponent. The only way to bring it down is to log both sides. And then we're able to bring that down. So now we have the log of 2400 equals 2x times the log of 10. Log of 10 is 1 again, so you could just drop that off at this point if you wanted to. If you didn't know that, how do you get the x by itself? They multiplied both of these, so I could divide by the 2 times the log of 10. And then the 2's are gone, and the logs of 10 are gone. And then I'm going to put that in my calculator. The log of 2400 divided by, I'm going to put parentheses around that, 2 log 10. And I should get 1.6901. So x equals 1.6901. There you go. The next one, being that we have an e as a base, we want to do the natural log, not the log, because the natural log has a base e. So again, the variable is in the exponent, so I'm going to natural log, both sides. And then I can bring that down in front to get the natural log of 54.6. It's just a number. I don't care what it is right now. But if you remember the shortcut, the natural log of e is just 1. But let's say you didn't know that, then you would divide by the natural log of e. So I have the natural log of 54.6 divided by oops, I need to end parenthesis that, the natural log of e, and e ends up to be, I do second and then I do the natural log to get to the e to the first. And you're going to get 4.0000, and then you're going to round it to the 0 because the next one is 3. So x equals, here we go. And if we take a look at this one right here, in order to natural log, we don't want this 13 sitting inside. We don't want to do this because then we got this 13 to deal with. And that's going to be a lot more difficult. So what we're going to do is we're going to divide by 13 first, which is going to give us 400 equals e to the 2x. And then we're going to natural log both sides, because then we can bring the 2x in front of it. So we have the natural log of 400 equals 2x times the natural log of e. And then we're going to divide both sides by 2, or 2 the natural log of e. Natural log of e is 1, right? So I don't even have to do the natural log of e after it. So x equals natural log of 400. And I just want to put that on my calculator again so you can see that. Make sure you put an end parenthesis before you divide it by 2, because you want to take the natural log of 400, that number, divided by 2. You don't want the natural log of 400 divided by 2, which is 200. You don't want the natural log of 200. So be really careful when you put that in your calculator. And you should get 2.9957. Moving right along, we want to solve this equation. So again, I want to get this base by itself. So I'm going to divide by 2 first. So then I have 6 to the 2x equals 1296. And now I can find the log of both sides. And then I can bring the 2x down in front. So I end up with 2x times the log of 6 equals the log of 1296. And I want to get the x by itself, so I'm going to divide by the log of 6, 2 times the log of 6. And those are gone, that's gone. So I end up with x equals, and I'm going to put this whole thing in my calculator. Make sure I parenthesis that. This is going to naturally parenthesis. This is going to naturally parenthesis. You don't want to over parenthesis things and it gets us into trouble, but you should get 2 when you put that in. Okay, so a little bit more complicated on this one, but I would treat the natural logs just like you would a variable. You want to get them both on one side. So I'm going to add the natural log of 3x to both sides. That's going to get rid of that. And then I end up with, when I'm adding, I'm multiplying these, right? So I'm adding, so I'm multiplying those. So I'm going to put these together by multiplying. So this is going to be the natural log of 3x cubed. X squared times 3x is 3x cubed. And then over here, I'm just left with the 12.18. And then in order to move forward, there's nothing else I can do. The x in this case, if you look at this, the x is within the natural log. The only way to break it out is to change this, go exponential. To break out an x out of a log, you can't separate these. This is one unit. The only way to get the x by itself is to break it out. So I go exponential. The base is e there. So I'm going to say e to the 12.18 equals 3x cubed. Very different than when I had the x as an exponent. In order to get it down, I had to log it and then bring it down. In this case, it's within the log. It's not in the exponent, so I have to go exponential to break it out. Now the x is sitting there, so now I can divide by 3. And I'm just going to leave this alone. I know it's a number, but I don't want to do anything with it yet. And then how do you undo a cubed? You cube root. And then that's going to take care of that, and I'm going to have x equals whatever this right here is. I'm going to put that in my calculator right now. So I'm going to do the cubed root, number 4. Oops. Try that again. Number 4. And then I have e to the 4.18. And I'm going to move it over 1, and then I'm going to divide that by 3. Notice everything's under the root. And here's my final answer of that. So make sure that you're able to punch that in your personal calculator so that you don't have any issues with that on a test. So I got 2.7930. Okay, let's try another one of those. So again, this is an equation, and I'm trying to solve for x. I have 2 of them, so I need to move 1 over. And so I'm going to add 2 natural log of 7x. Add 2 natural log of 7x. It's going to get rid of that. So then in order to put these together, though, I need to move this 2 back up into the exponent where it would, so I'm kind of like going backward on that 1. So now I have the natural log of x plus the natural log of 7x squared plus 6 equals 10.19. So be really careful that you move that 2 back up. It can float back and forth depending on what you're doing and what you need it for. I can't have a number in front of the natural logs if I'm going to put those together. And I want to put these together. I'm adding them, so I need to multiply. So I'm multiplying the x and this, and be really careful that you have parentheses around that because you're squaring this whole thing, whatever that is. So then if I do that, this is the same as x times 7x times 7x, right? 7x squared. I'm just showing you it over there. So it's 49x cubed. So this is going to be 49x cubed equals 10.19. So there's nothing else I can do. The x is connected to the natural log. The only way to break it out is to go exponential. And I have an e as a base here. So I'm going to go e to the 10.19 equals 49x cubed. And then I'm solving for x, so I got to divide by 49. And then I'm taking the cubed root. So that I'm left with just x on this side because the cubes cancel each other out. So if I were to put that in my calculator, I'm going to do the cubed root of e to the 4.19. Do the space there so I can divide by 49. And that gets me 1.1045, rounding it out 4 places. Okay, so the next one is the change of base. And I don't know if that was in our notes or not. I don't see it. So I will put it there. I'm going to actually go back to the very beginning, and I'm going to add a couple things on the screen right here that we had. So the natural log of e is 1, another little shortcut. The log of 10 is 1. And then remembering that the log base a of b equals x, to convert that to exponential would be a to the x equals b. So if you want to put these in your notes also, that would be wonderful. And the change of base is what I want to go over right now. And I'm going to put that on here also, so you have it. Oh, I have it right here. So if I have log base A of x, that can be the same as the log, and this should be a 10 and a 10. So this would be the same as the log of x over the log of a. So notice that the x goes on the top, the a goes on the bottom. And I'll just rewrite that. Log of x over log of a. You wouldn't even need the 10 base because it's given it's a 10 base. So knowing that, we're going to go back to this problem right here. I don't know what the log base 6 of 18 is, but I know that can be converted to a base 10. So that'd be 18 over the log of 6. If you put that in your calculator, you would get that. Okay, the next one, solve these equations. So again, the x is connected to the log. The only way to disconnect them is to go exponential. So it'd be 4 to the negative 2 equals x. And 4 to the negative 2 is the same as 1 over 4 to the positive 2, which is 1 over 16. Here's another one. So I need to get the log x by itself, so I'm going to subtract 4. So I end up with 3 log x equals 6. And then divide by 3. So I end up with the log x equals 2. And there's the only way to separate the x with the log is to go exponential. And you know that the base of that is 10. So I have 10 squared equals x. 10 squared is 100. Okay, let's take a look at this one, another equation 1. So I got to get the x's together. So I am going to move this one over. And when I do that, in order to put these together, we'd be dividing. First thing I need to do is move that 3 back up there. So now I'm going to do the natural log of x cubed over 3x. So when I'm subtracting logs, if I'm going to merge them together, I need to divide. Equals, and I'm going to subtract 8 from both sides. So that's just going to be 4.18. And then in order to separate these, so I could simplify this, and maybe I want to do that. So maybe I want to, there's 3 on the top, 1 on the bottom. So I'm going to make that 2 on the top. So I could simplify that. And then in order to separate an x from the log, I need to go exponential. And I know the base of that is e, so it's going to be e to the 4.18 equals x squared over 3. And then I'm going to multiply by 3. And then I'm going to take the square root. So if I was going to show that on my calculator, I'm going to do the square root of, what was that again? 3 times e to the 4.18. And there's my final answer. So x equals 14.0035. All of these, you could take your x, plug it back into the original equation, and come out with what you have on the left to what you have on the right. It should be really close. We had to do a little rounding, but they should be really close if you want to double check, which I would probably do on a test. Last one, solving. So I want to get the logs together first. So I'm going to, change my pen first. going to do the log base 2 of x minus the log base 2 of 5 equals 3. So that one's gone. And I'm subtracting, so I would divide these. So I'd have the log base 2 of x over 5 equals 3. And then the only way to get the x and the log separated, I know I said this a lot, but I want to make sure you're getting this, is to go exponential. So it'd be 2 to the 3 equals that. And then I'm going to multiply by 5 on both sides. And then x is going to end up to be 40. There you have it.